Let us look at angle between radius vector and the tangent. So let's take a function r is equal to f of theta. So this is basically in the polar form. Okay, so given a function r is equal to f theta, take a point P and the coordinates are given in Cartesian form, x comma y. So let's take that point. This is an arbitrary point, so we can take it anywhere. Draw a tangent T and the radius vector r. So this is the origin. This tangent forms an angle with the x-axis gamma. The radius vector forms an angle theta with the x-axis, and the angle that we are actually interested in is between the radius vector and the tangent. So let's call that theta. So we want to arrive at a general expression for finding the angle beta. Let's draw a perpendicular from P and let's name this point as C. So we end up with a right-angled triangle. So in this right-angled triangle, what do we get? We get cos theta is equal to adjacent side by hypotenuse. So this is x divided by r. So that means x is equal to r cos theta. Similarly, y is equal to PC is y. So y is equal to r sine theta. Tan theta is equal to y opposite by adjacent. So y by x. So angle itself becomes theta is equal to tan inverse of y by x. Our function is r equal to f theta. And here we have x equal to r cos theta. So which means we can write x as f theta times cos theta. Similarly for y is equal to r sine theta. We can write it as f theta times sine theta. Now let's differentiate these two. Dx by d theta is equal to f theta as it is, derivative of cos theta, which is minus sine theta, plus cos theta as it is, derivative of f theta is f prime theta. Now the second one, dy by d theta. So here we are differentiating with respect to theta. So dy by d theta is equal to f theta as it is, sine theta is cos theta, plus sine theta as it is, the derivative of f theta is f prime theta. We know that dy by dx is the slope of the tangent, that is tan gamma. So since we are interested in this slope, we are interested in dy by dx. But here what we have as of now is dx by d theta and dy by d theta. But we also know that gamma is equal to theta plus beta. Gamma is equal to theta plus beta. On what basis? Because this is an external angle to this triangle. That means it is equal to the sum of the interior opposite angles. So dy by dx is equal to tan gamma. We have already seen. This can be written as dy by dx is equal to tan theta plus beta. Okay. Using dy by d theta and dx by d theta, we can arrive at dy by dx by dividing dy by d theta by dx by d theta equal to tan theta plus beta. So right hand side we just keep carrying. Dy by dx equal to, remember we are dividing these two. So dy by d theta is f theta cos theta plus f prime theta times sine theta divided by dx by d theta, that is minus f theta sine theta plus f prime theta cos theta is equal to tan theta plus beta. Dividing the numerator and denominator by f prime theta cos theta. So we will divide this, and we also know that tan theta plus beta, that is tan of a sum of two angles, is equal to tan theta plus tan beta divided by 1 minus tan theta tan beta. So let's do the division. dy by dx is equal to f theta cos theta divided by f prime theta cos theta. Similarly, this term as well, all the terms is equal to tan theta plus beta. dy by dx is equal to, now there will be cancellations. Cos theta gets cancelled. We are left with f theta by f prime theta. Here f prime theta cancels. Sin theta by cos theta is tan theta. Here this is, we are starting with a negative term. So let's exchange it. So let's rearrange this so that we get f prime theta cos theta divided by f prime theta cos theta. So both gets cancelled. We are left with 1 minus f theta by f prime theta times tan theta. This is equal to that tan theta plus beta. We apply the identity. Tan beta plus tan theta divided by 1 minus tan beta tan theta. Here, compare the terms. Here you have tan theta, here also you have tan theta. Yes, here you have 1 minus, here you have 1 minus. Tan theta is there here, here also tan theta is there. Here you have tan beta and here you have f theta by f prime theta. But tan beta is also here. So there also, if you notice, there also it is f theta by f prime theta. And we know the overall, they are equal. So that means f theta by f prime theta is equal to tan beta. Now let's deviate a little bit. We know r is equal to f theta because we need this f prime theta. So we need to arrive at that. So r is equal to f theta. If we differentiate it with respect to theta, we get dr by d theta is equal to f prime theta. So tan beta is equal to f theta, which is r, divided by f prime theta, which is dr by d theta, which is equal to r times d theta by dr. So finally, we can say that the angle beta is equal to tan inverse of r times d theta by dr. This is the expression by which we can find the angle between the radius vector and the tangent at a point on a curve. Remember, this is an arbitrary point. So as you keep moving this point on this, this expression will always give you this angle beta. So just as a reminder, there is a link to a PDF book which describes all these things in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.